taking a look at Chapter 8. Chapter 8 is going to be about probability, and Section 1 is about experimental and theoretical probability. Now, when we talk about probability, we're talking about outcomes. So what's the result of a situation or a result of an experiment? And then we have a thing called sample space. Now, sample space is just the total possible outcomes. Okay, so like if you flip a coin, you have two possible outcomes, right? Heads or tails. Going into probability, the definition, it's a fraction or division, the number of favorable outcomes, what we want to happen, over the total possible that can happen. So if you're flipping a coin and you want heads, that you only want one of the outcomes out of the two possible outcomes, right? So there's a 50% chance, and that's kind of theoretical, just the kind of possibilities without actually doing it. Now, if I flip the coin 10 times and it landed on head 6 times, then it'd be 6 out of 10 would be my experimental probability, and we'll get into that more. But if an outcome is for sure it's gonna happen, then it is a 1 or 100%. You can do percentages as well. And then a 0, it means it's not gonna happen. Okay, so the probability is how likely it is gonna happen. 0 being never, 1 being automatically. It's always gonna happen, right? And then, like I said, experimental probability, event that measures the likelihood that an event occurs based on the actual results of an experiment. So that's the number of times the event occurs, or the favorable outcomes, what we want to happen, over how many times possible, how many things we actually did, how many times we actually flipped the coin. So that's experimental. Okay, let's go ahead and look at a problem here. We're going to calculate the experimental probability. So we have a quality control inspector comes and sees 500 LCD monitors and finds that 3 of them are defective. So we have these numbers, right? 503 of them. We want to write the experimental probability that the monitor selected at random will have a defect. Okay, so that means we're looking at defects. That's our favorable, what we're comparing, defects to the total possible, which would be the total number of monitors. Total monitors. And this is experimental because we're actually seeing the 500 monitors and finding 3 of them that are defective. So my probability of defects is 3 out of 500. And I can leave it like that. I could do a decimal. I could 5. Let's see. 0.006, right? So I could do either one of those. All right, so there you go. That's kind of how you calculate it. What you want, or what you're looking for, over the possible, total possible. And experimental is how many times you do it, or how many things you look at. Here's a quick another example. So of those 500, 3 of them were defective. Okay, now what if the company manufactures 1,500 monitors in a month? How many are likely to have a defect based on our other experiment of the other inspector, right? So our probability of defects was 3 to 500. Now we want to find, okay, well, what if we do 1,500 of those? What's going to be the how many defects are we going to have, right? So the easy way to do is this: just take this number and times it by our 15,240, and that will tell us how much it is, right? So you could get the decimal and multiply that by 15,240, but this is how it's kind of set up, algebraically. because this is my fraction, defects over possible. And then I have defects, which I don't know of the 15,000 over possible. Right, so I'm solving for x. So I just multiply both sides by 15,240. So I just multiply that. Right, so I could do a few different things. And I could multiply these two and then divide by 500. I could divide these first and then multiply by 15,240. Or I could take 15,240 divided by 500 and then times by 3. It's just algebra. So I get 91.44, so about 92. So about 92. All right, so that's how you use it to predict. You use your probability to then adjust that to a larger size, right, to figure that out. Okay, so here's a got it that you can do. You have 538 trees. You choose 40 at random. So that's how many total there are, like, of trees. But you choose 40. So that means you're only looking at 40 of them and determine that 25 of those 40 trees are, let's see. You choose 40 trees at random and determine 25 of those 40 are maple trees. Okay, so you want to write an experimental probability for that, and then you're going to do just like I did on part B. You're going to use the new total with that same probability of your your total number of trees that you looked at over what you found. And you're going to do it the same thing.